Okay, good evening to everyone. Give me a confirmation if you guys hear me. Good evening to everyone. Give me a confirmation if you guys can hear me. Yes or no. Can you guys hear me? Yes or no? Please respond. Okay, good evening, everyone. Awesome. So, welcome to day 5th for this bootcamp of Python and machine learning. So far, we have understood about Python. We have seen what are different types of concept in Python, such as data structures, conditional statements, loops. Apart from that, we have discussed a little portion about machine learning as well yesterday. And why machine learning is being used, we have emphasized on the topic of data, how company generates data, how we get data, and what is the importance of data and how data is different from information and how you can use data to generate revenue profit and what no what you can do with the help of machine learning. Today we are going to emphasize more on machine learning and we are going to look forward to one of the algorithm called as linear regression. A very simple linear regression we will to understand about the concept, and we are going to see how we can use the linear regression to predict something that will going to happen in the upcoming time. So before going on, just give me a confirmation if my voice is audible to you. Just give me a confirmation if my voice is audible to you and it is good enough to hear. Is it? Awesome. Cool. So, shall we start with our today's session? Shall we start with our today's session? OOPS is a concept. OOPS is a way that focus on the concept of code reusability. Okay, OOPS is really important whenever you are working in a software industry. Okay, not only specific to Python but for all different programming languages, OOPS is important. Okay, awesome. So before starting, I have a question for all of you. I have a question for all of you. Is data and information same? Is data and information same? Yes or no? Come on. Is data and information same? Let's see. No, exactly. See, data is different and information is different, right? When we work with machine learning, we work with information. Now, this is very important. Now, we are going to go in the advanced concept. Okay. So, now keep this in mind that whenever we work with machine learning, we use information, we never use data. Okay, so now in order to convert this data into information, what we have to do, we have one procedure in between. Okay, we have a procedure. Okay, this procedure takes an input as a data. This procedure takes an input as a data and it gives an output as an information. Can anyone name what is the name of this procedure? Can anyone name what is the name of this procedure? Let's say, and more specifically, we can call this as a raw data, totally raw data. Anyone know what is the procedure name that helps us to convert raw data into information? Exactly, it's data analysis. It's data analysis. Okay. However, we are not going to talk about data analysis in this session, but this thing you need to keep in mind that whenever you do machine learning, you directly don't go up with machine learning. Let's suppose you get a data and you start building a model, right? Never. First of all, you have to make your data clean. You have to manipulate the values. You have to have visualization from the values, and when you are done with that, you give information and this information will be correct. So now this information is totally dependent, not this information but the machine learning performance, your model performance. Let me write over here, ML model performance. depends on information as well. So there are various factors on which the model performance works. So when we work with machine learning, we try to attain a higher performance. Okay, and this performance is known as the accuracy. We try to have a higher accuracy for a model, and one of the factor is your information. Okay, the more good your information is, more better your information is, more higher accuracy you will going to attain. Is this clear? Is this clear, everyone? Yes or no? Is this clear, everyone? Yes or no? Okay. Now there's one more question arises, is that what is the difference between machine learning and data analysis? Are they both same? Is data analysis and machine learning same? Come on. Do you think they both are same? Anyone? Do you think they both are same? No, they both are absolutely different. They both are absolutely different. Data analysis tells the present situation about the data. Okay, whatsoever insight you can gain from the data, it will going to tell. However, machine learning takes the data and predicts the future. Okay, let's understand with this for an example. How many of you have watched Spider-Man No Way Home? Anyone? How many of you have watched Spider-Man No Way Home? Anyone? Let's see. Any Marvel fan over here? Okay, awesome. So so Spider-Man came around December 2021, right? Let's go back. Let's go back around August 2021 when the first trailer of Spider-Man came into action. Okay. Now, when we have seen the trailer, you all must have seen the trailer, right? At then in the trailer is your data. Over here, trailer is your data. Now, with respect to that trailer, what analysis you can do? I can say, with respect to that data, I have seen that Goblin, definitely Goblin will be there in the movie. I have seen the Goblin, a pumpkin ball, so I can say that Goblin will be in the movie, right? This is not a prediction. This is not a prediction, guys, right? Because I have, with the respect of something, I'm telling that he will be there. Then I have seen that Doctor Strange will be there, right? Then I can say that Doctor Strange will be there because I've seen that in that trailer, right? Then we have different characters. However, this is what data analysis is. Based on the trailer, you are telling that Goblin will be there, Doctor Strange will be there, and certain people will be there, right? Now when we talk about ML, then I can say that hey, there will be three Spider-Man. There will be three Spider-Man. Now tell me, if you have seen the trailer, in the trailer, do we have three Spider-Man? In the trailer, do we have three Spider-Man? Yes or no? Do we have three Spider-Man in the trailer? No, right? 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 Then how do we know? How do we know that there will be three Spider-Man? Because based on various factors, based on this, these are the data that we have gained from the data analysis, and based on this data, we have predicted that okay, there are different villains. There is Goblin, there is Sandman, there is Doctor Octopus. So definitely there will be three Spider-Man. We are not sure. We are not sure that whether they will be there, but we are predicting, right? So over here, when we use the word prediction, okay, the word probability plays a very important role, because I have already told you, when we do a prediction, it is not the thing that it will has to be 100% accurate, right? It can be, it cannot be. It can occur, it cannot occur. Same example, let me give a same example. How many of you have watched Doctor Strange Multiverse of Madness? How many of you have watched Multiverse of Madness? Anyone? Anyone? Anyone who have watched this movie? Right? So now again the same thing. If you go and see the trailer, you will going to see various factors. Okay, there will be a Doctor Strange, there will be a Sinister Strange, and so on and so forth. And one more thing we have found, there will be uh They will be the Illuminati. Yes or no? They will be the Illuminati group, right? We have, how we know that they will be in the movie, because we have seen that in a trailer. But based on this factor, we have also predicted that there will be superior Iron Man. Yes or no? Based on the factor, based on this factor, we have predicted that there will be superior Iron Man as well in the movie. But was he there? Was he there? Yes or no? Was he there? No, right? He wasn't there. So over here also we have done a prediction, but over here we have failed to do so, right? So when we talk about prediction, when we talk about probability in machine learning, it means that we can give you a certain amount of surety that an event will going to occur, but we can never sure that the event will surely going to occur or surely will not gonna occur. Is this clear, everyone? Is this clear? Is this clear, everyone? Yes or no? Okay. Okay. Is this clear, everyone? Yes or no? Awesome. So now this is a concept, how data analysis is different from machine learning. I hope this is clear. Why we use machine learning, what is data, and so on and so forth. So in a comparison, we can say a machine learning is a subfield of data or subfield of computer science that gives the computer the ability to learn without being explicitly programmed. It gives the ability to a machine to learn from itself. Over here, we don't need any human to make us learn, right? So now when we go deeper in the concept of machine learning, there are different types of ML. There are different types of ML, right? And there are three types of machine learning that we study. One is your supervised learning. One is your supervised learning. Another is your unsupervised learning, that is your opposite of your supervised learning. And lastly, it is your reinforcement learning. Okay. Now, supervise mean that you are working under someone's supervision. You are working under someone's supervision. So over here, you can say teacher. You have a teacher with you, right? Now, what exactly is the role of a teacher? He or she will going to correct you on your mistake, and based on that mistake, the next time you will try your best not to repeat that, right? In the same case over here, when we say supervised learning, right? Let me give you a brief about data itself. Like suppose this is our data. This is our data, right? In this data, we can have multiple data. Let's say we have a student name, we have a city where they belong from, and how many marks they have got in mathematics, science, and so on and so forth. And according to that, we have a result, whether they are pass or they are fail. Okay, it's just like that. Suppose you are having an exam in the upcoming time, and you are let's suppose you have a maths exam in the upcoming time, right? And now you have to practice maths. Now you have taken a equation, and you are solving that equation. You have found an answer. Now you are rectifying whether the answer you have got is correct or not. How do you rectify that? You look onto the book, you look onto the solution, right? And on that solution, you will going to see whether your output or whether your answer is correct or not, right? So over here, you have been given a entire booklet, an answer key, where you can verify. You have a question as well, you have an answer as well. You take the question, solve the answer, and match your answer with that answer key, right? So in this case, your answer key will be a supervision, right? Is this clear, everyone? Yes or no? Is this clear? Right? So if we talk about the proper definition of supervised learning, then we can say it is a type of machine learning that uses label data to train the algo. Let me write this over here. It is the first type, or you can say it is one of the type one of the type of ML that uses the label data. Okay, that uses the label data to train the algo. That's it. Okay, so this is what machine learning is, that whenever you talk about data you get an answer key. How exactly we can relate this? We can say, let's suppose we have a question. Let me create a data. Let's suppose this is our data. Okay, on the left hand side I am having a question, and on the right hand side we are having the answer of that question. Let's say question, and we have answer. Okay, now let's say question is 2 plus 2, and corresponding to that we have a solution as 4. Let's say we have 4 into 2, and we have the solution over here, right? So over here you can see we have the question paper, right, and the answer key as well. When we talk about supervised learning, we have been given an answer key. We have been given an answer key, so that when we train ourselves with the data and we test ourselves, we can easily check whether our answer is correct or not. So in an examination, so this is about the practice session, right? But when you go to the examination, in the examination you only get a question paper. In examination you only get a question paper, you never get an answer key, right? So in that case you cannot verify whether your answer is correct or not, right? So what will going to happen? You will going to train your model with this data, the question paper and the answer key. Let's suppose a model start with the first question, 2 plus 2, and they have predicted that 2 plus 2 is 5, right? Now they will going to see whether this 5 is correct or not. Then it will going to look, no, the correct answer is 4. So based on this experience, machine will going to correct itself, so that in the upcoming time if certain cases appear, machine can give us accurate result. Okay, so the motive of machine is not to give you the perfect result. Motive of machine is to give you an accurate result that will be nearer to the actual value. Is this clear? Is this clear? Yes or no? Is this clear? Yes or no? Okay, is this clear, everyone? Awesome. So this is all about supervised learning. Now we talk about unsupervised learning. Unsupervised learning is opposite of supervised learning. That it is one of the type of ML that use the unlabeled data to train the algorithm. So in this case, we don't have any answer key during the training session. We don't have any answer key during the training session. When we talk about unsupervised learning, it is fully based on the customer perspective. Okay, so when you want to study the customer behavior, okay, we use unsupervised learning. Company like Amazon, Flipkart, Alibaba, Google, or any other company, any other e-commerce company, or those companies who sell some service, they use unsupervised learning. Let me show you an example. Let's go to amazon.com. Let's say Amazon. Okay, let's go to amazon.in. Let's search for some product. Let's say laptop. Okay, so let's say this one. Now see this. Everyone know what is amazon.com? Everyone knows what is amazon.com, .in.com, Amazon? Yes or no? Jeff Bezos? Yes or no? Everyone knows, right? Yes or no? Okay, so now see how Amazon is using machine learning. Let's see how Amazon is using machine learning and all this algorithm. Now see, I have searched for a laptop. Now I think that I should go with this laptop. This laptop looks good. I'm going to go with this laptop. But if I scroll a bit, you can see a section where it is written buy it with. Can you see a section where it is written buy it with? And we have been shown 3 products. we haven't shown 3 products, right? So these are the products that has been used more frequently. This says algorithm over here is being used as a priori algorithm. Okay, the algorithm over here that has been used is an a priori algorithm that is based on unsupervised learning. Okay, over here what happened is, now it says that if some user is purchasing this laptop, so there are high chance the user will going to purchase these 2 products as well. In a very simple language, if someone is purchasing bread, then there is high chance that they will also going to purchase butter and jam. Are you guys getting this? Are you guys getting this? Yes or no? If someone is purchasing bread, then there is high chance that they will going to purchase butter and jam as well. So similar thing over here has been done. If someone is purchasing this product, so there is high chance they will going to purchase a cover to protect their laptop, and they will going to purchase a mouse as well, right? And this is not something that is coming directly from the database, right? So this is a high this is a priori algorithm that has been used. So this is known as, is this clear? Is this clear? Awesome. So this concept is known as the market basket analysis. This is the market basket analysis. If you want to search, you can search the algorithm. This is the entire psychology. It plays with the psychology of a customer, that what customer wants and how we can make them to choose multiple products. Similarly, if you come slide down, you will going to see products related to this item. You can see products related to this item, and over here as well, if you scroll down, you can see explore more from Acer products related to this item. This is known as a recommendation system. This is known as a recommendation system, guys, right? So based on our search, the algorithm is recommending us more similar product. It could be similar Acer company, it could be similar Gen company. If you watch Netflix uses recommendation system. If you have watched a movie, then it will going to show you some recommendation based on, it might be on different genres, it might be on the same actor, it might be same climax, or so on and so forth, right? So all the companies are using recommendation system, a priori algorithm, and various other machine learning algorithm to boost their sales. Okay, is this clear? Is this clear? Right? So machine learning is very important, and the machine learning type, unsupervised learning, is totally based on understanding the customer behavior. It is totally based on understanding the customer behavior. So in this case, we don't have any answer key. Is this clear, everyone? Is this clear, everyone? Yes or no? Kindly give me a confirmation, please. Awesome. Now let's talk about the reinforcement learning. Okay, so these are the 3 primary types of machine learning. Okay, if you go on search, you can find multiple other types such as semi-supervised, so on and so forth, but these are the primary ones. Okay, those are the secondary ones. Now reinforcement learning is very important. Reinforcement learning is based on the concept of game theory. Reinforcement learning is based on the concept of game theory. Okay, a better example of reinforcement learning, Tesla cars. Tesla cars. Anyone have heard about Tesla cars? Autonomous cars. Anyone? Right? So they perform the game theory. Okay. So in the game theory, what happened is, let's suppose you play a game such as Mario. Everyone might have played the game Super Mario or anything related with Mario. Right? So how exactly a game work is, if you collect, so let's suppose this is our player Mario, right? If you collect certain coins, you get some additional power, your power will be boosted. But if you touch your enemy, what will going to happen? Your power will going to decrease, or you will going to die, right? Now for the first time when I'm going to play a game, I don't know how to play, I don't know how to gain point, I don't know how to defend this enemies and all that. So what happened is, for the first time when I played, I went there and suddenly what happened? This enemy has touched me, so I died. So now I know that I have to beware of this enemy. I don't let this enemy to touch me. This was my experience. This was my past experience, and based on this past experience, I'm going to use it for the next time, so that the next time I'm not going to make any mistake, right? So this is a game theory that has been used in the reinforcement learning. So what happened is, during 2012 or 2011, Google was working on reinforcement learning, and they have developed a bot. Okay, they have developed a bot and trained that robo to play a game known as AlphaGo. The game name was Go. Like we have chess, checkers, and all that. So the game name was Go. Okay. Yeah. So what happened? They have developed a machine, AlphaGo. Now they have conducted a worldwide tournament. They have conducted a worldwide tournament with the you can say monarch of the game Go, who is the champion in game Go. So there was 5 matches. Among those 5 matches, 4 matches was won by the AI. 4 matches was won by AI, that is known as AlphaGo. And there's a good documentary that has been made based on this. You can check out YouTube. Okay, let me share that as well. It's a very informative documentation. Let me show you. AlphaGo. So this is the documentary. This is the documentary. Please see this documentary whenever you get a time. You get a huge, idea how exactly machine learning works. Okay, and how exactly reinforcement learning works. Okay, kindly check this link out. So reinforcement learning based on the game theory. We use this to develop a machine so that they can perform and they can take decision based on their previous experience. Is this clear, everyone? Is this clear, everyone? Yes or no? Is this clear, everyone? Yes or no? Okay. So this is the 3 types of machine learning. Now let's see what are the different algorithms that we get in supervised and unsupervised learning. The very basic algorithm that you get in supervised learning, there are 2 types of supervised learning over here. There are 2 algorithms. One is your regression and another is your classification. Okay, let's write this over here. You have regression and one is your classification. One is your classification. In regression, we have different algorithms such as linear regression. You have random forest regressor. You have, let's say, what's the next one? You have decision tree regressor. You have SVR. Okay. So these are some of the regression techniques that we have. Similarly, when we talk about classification, we have logistic regression, we have KNN, we have decision tree classifier, we have random forest classifier, and we have support vector classifier. Right? Now, how to choose regression and how to go with classification? How can we decide this? How can we decide this? Right? So it's totally based on the data. It's totally based on the data. Whenever we say that in supervised learning we use a label data, this means we have a target value. Now based on this target value, we choose whether we have to go with regression or we have to go with classification. Okay, till here is it clear? Till here is it clear? Till here is it clear, everyone? Yes or no? Okay, perfect. Now in this answer key, whatsoever value is being inserted, right? Based on that value, you will going to decide whether you have to go with regression or you have to go with classification. You will going to go with regression when the output or the target value is a continuous value. Okay, whenever your output is a continuous value, or a numeric value, you have to go with regression. Whenever your output is a categorical value, you have to go with classification. Okay, let me open one more tab. Let's say one more. Okay, so now when we talk about regression, the output value should contain the continuous value. Okay, the output or the target variable should contain continuous value. Okay, what are continuous value? 54.8, 1.0, and so on and so forth. But when we talk about classification, the output or your target variable should contain categorical value. Such as male, female is your categorical value. Yes or no? Right? Male, female is your categorical value. A precise range, let's suppose 0 to 10, 10 to 20, and so on and so forth, is your categorical value, right? So if your output is a categorical value, then you have to choose classification. If your output is a continuous value, then you have to go with regression. Till here, is it clear? Yes or no, everyone? Okay, perfect. And these are the supervised learning. Similarly, in unsupervised learning, we have clustering and we have association, right? So in clustering, we have algorithms such as k-mean clustering. Okay, we have algorithms such as k-mean clustering. You have hierarchical clustering. In association, we have a priori, we have eclet, and the association part focus on the market basket analysis and the recommendation system. Always remember this thing. Association part focus on the market basket analysis and the recommendation system. Okay, so now in this entire bootcamp, we will be going to discuss about regression and one of the algorithm of regression, that is your linear regression. We are going to talk about a linear regression. Okay, we are going to talk about linear regression and how exactly linear regression works. Till here, is it clear? Everyone? Yes or no? Okay. Now, so linear regression is one of the easiest and most popular machine learning algorithm. Okay, it is one of the easiest and most popular machine learning algorithm. Okay, we use this linear regression for the predictive analysis. What is a predictive analysis? When you want to predict something based on a factor, you predict something, right? Similar that we have predicted for the Spider-Man, that based on certain factor, 3 Spider-Man will be there. In that case, we can use linear regression because it is used for the predictive analysis. So linear regression makes a prediction for the continuous or real numeric value. Because it is a part of regression, so the target value should be a continuous value. Okay, so let's suppose, for an example, you want to predict the let's say you want to predict the salary. You want to predict the salary of a person based on the hours of the working, how many experience they have, and what job they do, and based on that you can predict the salary of that person, right? So that all has been occurred with the help of linear regression. Now linear regression works in a way of the dependency. Linear regression works in the way of the dependency. So the linear means straight. Linear means a linear line that shows the connection between two entities. Okay, that shows the connection between two entities. Okay, is this clear? Till here, is this clear, everyone? Yes or no? Okay, cool. Now, before going on to understand about linear regression, you need to understand about two terms. That is your input. We call input as the we call input as your independent variable. Okay, we call input as the independent variable, and we call this as feature as well. So, independent variable, and output is known as target or the dependent variable, or the dependent variable. Is this clear? So these are some of the terms that you need to understand. That for input we use the term feature or independent variables, and for output we use the term target or dependent variables. Okay, now what happen is you have to plot a graph. You have to plot a graph. We generally plot a graph between the feature and the target to see what is the relationship between these two. If we have a higher relationship, we can conclude that yes, this feature is important, and based on this feature there is a high chance of a particular output to occur. Okay, so graph looks like this. Okay, so we have x-axis and y-axis. So on x-axis we have independent variable, that is your output, and on the y-axis we have your input. Okay, now if I say, if I create a line, a linear line like this, what can you conclude? What can you conclude based on this graph? What can you conclude based on these two graphs? We have a linear line. What can you conclude based on these two graphs? Come on, anyone? Anyone? Come on. Input is equal to output? No. Let's see who will going to answer this. I've already told you, machine learning, data science, we have to use mathematics, right? IP is proportional to OP. Partially correct. Partially correct. Exactly. Input is directly proportional to output. Input is directly proportional to output. That means if we go into this direction, we can see as the input increase, output will also going to increase. As the input will going to increase, output will also going to increase. Yes or no? Right? Are you guys getting this? Yes or no? Are you guys getting this? Yes or no? Right? Similarly, if I say in our case, input is our experience. Input is our experience and output is the salary. So you can say that experience and salary are directly proportional to each other. As you have higher experience, your salary will also going to increase. Yes or no? As you have a higher experience, your salary will also going to increase. Right? Now, this is something that we're predicting. This is something that we're predicting. In general case, if you take it, never happens. In most of the time, let's suppose you have 10 years of experience, but still you are working, there's an exceptional case. We have an exceptional case as well, right? But this is what we can use linear regression to predict about, that how exactly these two variables are related with each other. How these two variables are related with each other. If one is increasing, other is decreasing. If one is increasing, other is increasing. So based on these two, based on these factors, we use the linear regression. In linear regression, we try to find out the best fit line. So this line you can see over here, this line is known as a best fit line, right? This line is known as a best fit line. So what happened is, I have drawn a line like this, right? Now let's suppose another line. If I draw a line like this is also a line and it is also suggesting the same thing. This is also a line and it is also suggesting the same thing. As the experience increases, and output will going to increase as well. Yes or no? Yes or no? Right? Are you guys getting this? Yes or no? Okay. Now similarly, over here, let's suppose we have another line. We have another line. Let's say this line. This also is predicting the same thing. As experience increases, output will going to increase, right? So we have various lines over here. So in linear regression, what we do is we try to find a best fit line. We try to find a best fit line. Why we need to find a best fit line? That means we have multiple lines, and among those lines we want to find that specific line that gives us a more accurate value. Reason being is, let's suppose you say, I want to find out the salary if I have 10 years of experience, right? Let's say this line says that you are having the salary of, let's say, uh, 40 lakhs. This line says you have the salary of 50 lakhs. This line says you have the salary of 60 lakhs, right? In all of the cases, they both are increasing. They both are directly proportional to both experience and output your salary. However, which of the three values you are going to predict? Which of the three values you are going to take to tell the user that if you have 10 years of experience, then you can at least expect these many salary, right? So in linear regression, our motive should be to find the best fit line. And how we find a best fit line? We use the equation. You definitely must have heard about this equation: y equal to mx plus c. Anyone, have you guys uh, learn about this equation, y equals to mx plus c? Anyone? Y equals to mx plus c. Anyone? Right? So over here, now see, the thing is that it is very amazing, but we have already learned about no, most of the machine learning algorithm during our 11th and 12th, but we haven't know, because at that time we are not been able to figure out where we are going to use all this equation, right? So if you have learned about trigonometry, you will be wondering that how we are going to use this in a real life scenario. Machine learning, deep learning, data science is the field where you are going to use. This is your linear line regression. Over here you are going to use all the statistics that you have learned during your 11th and 12th. This is a place where you are going to use this. Okay. Over here, this y is your output variable, and this your x is your input variable. Always remember this thing. Over here, your y is your output variable, and your x over here is your input variable. That means y is your dependent variable, okay, and x is your independent variable. Is this clear? Is this clear? Yes or no? Is this clear, everyone? Yes or no? Come on. Okay, so over here, c is a constant and m is our slope. C is a constant and m is our slope. Okay. Now, generally, what is the, if I have to tell you the working, how exactly a working of linear regression happens? So what happens is that you have a data. Okay, you have a data set. We call this as a data set. And data set, let's suppose we have some data where we have experience. Okay, and another we have salary. Okay, we have salary. So let's say you provide a data. Let's say if you have 1 years of experience, then you can expect the salary of 30K a month. Okay, if you have 5 years of experience, then you can expect a salary of, let's say, 70K. If you have experience of 10 years of experience, then you can expect a salary of 1.2L. Right? Now this is your data. Okay, now if you want to do a data analysis, you can do anything. That if you have 1 years of experience, then you can get salaries such and so on and so forth. Now the question arises is that based on this data, you have to predict what will be the salary if a user has an experience as 15. If a user has an experience 15, what will be the salary? This is a prediction. This is a prediction, because if you look onto this data, if I give you the same question again, what will be the salary if a user has the experience of 10 years. So is this a part of machine learning? Is this a part of machine learning? Come on, tell me. Is this a part of machine learning? Is this a part of machine learning? Yes or no? Come on. No, guys, this is not a part of machine learning. This is a part of data analysis. Come on. Come on, come on, come on. This is a part of data analysis, because by looking at the data, I can tell you over here I'm not predicting. Over here, I am not predicting the values, right? Straightly, I'm going to look at the data and we're going to tell you the values, right? Over here, we are not doing any prediction. So this is a data analysis, right? But when I say you have to find the salary where the experience is 15, so over here we don't have any such values. Now we have to use, now you have to tell the value or the salary, we have to predict the salary based on the given data. So this is what machine learning is this clear? Is this clear? Yes or no? Is this clear? Yes or no? Perfect. Now what will going to happen is you provide this data to your machine learning model, that is your linear regression. Okay. So over here we have a model, linear regression model. You will going to provide this to your linear regression model. Now what will going to happen in the backend is your linear model regression will going to use the formula y is equals to mx plus c. Okay. So now for the first data, it will going to learn about all the data. Let's say for the first data, y is, what is y over here? Y is your 30k. So it will be 30 equals to m into what is your x, that is your 1 plus c, right? This is your first equation. Yes or no? Yes or no? Are you guys getting this? Yes or no? Okay. Is this clear? Right. Now again it will going to take the second equation, third equation, and based on that it will going to find out the value of m and c. It will going to find the value of m and c, because we know that over here we have been given the value of y. We have to find the value of x, right? And we have to use this equation to find the value of x. So we already know y, but we don't know what is m, we don't know what is c, right? So based on this equation, based on all of this value, we put that into an equation to find a suitable MNC using the concept of gradient descent. Okay, that's a very advanced concept, we are not going to touch that. Okay, but just try to understand, LR model will going to try to find out the most suitable value, of MNC, not the accurate value. Your model can never give you an accurate value. Always remember this thing. None of the model, if you might have studied about this during your school time, that none of the machine is 100% efficient. Have you guys heard about this term? None of the machine can be 100% efficient. No machine can give you 100% efficiency. Are you guys getting this? Yes or no? Right. So that means in your model you can never get 100% of accuracy. You can never get your 100% accuracy. Your motive should be to get a value that is nearer to your actual value. For an example, let's say, let me make you understand. Let's say we have sun. We have sun, right? Now scientists predict that let's suppose the temperature at sun is x degree Celsius. The temperature at sun is x degree Celsius. Now tell me, has any scientist went to sun to take the reading or the temperature to find out the temperature of sun? Has any scientist went to sun to find out the temperature? Yes or no? Anyone? No, obviously not, right? Let's suppose the original value. For an example, let's suppose the original value of the sun temperature might be x plus 23. Might be x plus 23. But now what we do is we try to predict a value that is near the actual value. That's why we call this as the actual value, and we call this as the expected or predicted value. Okay, we call this as a predicted value. Now what will going to happen with more advanced technology in the upcoming time, it might happen we say that no, the temperature of sun is not x, whereas it is x plus might be 18. It might be 18. Now see, we are moving closely to the actual value, but we cannot reach the actual value itself. Similarly, if you might have studied chemistry during your school time, first of all, a Rutherford comes up and it says that Rutherford had done something, and as soon as you studied Rutherford, then the statement comes up that oh, Rutherford was wrong. Now we have Jason model. Now, as soon as you go with the J.J. Thomson model, again there is an exception that no, J.J. Thomson model is wrong. Yes or no? Yes or no? In chemistry, we have seen a lot. So what happened is, as the scientists go on and on and on, we get a different values, and those values are nearer to your actual value. Okay. Similarly, our motive of any kind of model will be. Don't ask me who is Rutherford. Okay. I hope that everyone knows about who is Rutherford, right? Cool. If you don't know, then please don't know about him. Okay. Cool. Now, the motive of all the model will be to predict the nearer value. Okay, so we will be getting the most suitable value of M and C based on all this algorithm. Now you have the value of M, you have the value of C. Now, based on the equation of y is equals to mx plus c, you will going to put the value of y. In our case, the value of y is 10. You will going to put 10. You will going to put the most suitable value of m over here. You will going to put the most suitable value of c over here. And with all this, you will be getting the value of x. You will be getting the value of x. Is this clear, everyone? Yes or no? Come on. Is this clear, everyone? Yes or no? Okay. Okay. Cool. Now there's one more concept. It is the concept of matrices, not matrix. Matrix is different and matrix is different. Okay. So we use the matrix. Matrix helps us to find the accuracy of a model. That means how accurate our model is. Okay. How accurate our model is. So based on that, we use the matrix to find out the accuracy. Okay. So we have different types of matrices. We have MSC, MAE, RMSC, RSC. So they are different types. But you just need to understand what exactly matrix do. It helps us to find out the accuracy of a model. Okay. Now, how exactly the working of a machine learning algorithm works? So what will going to happen is you will be provided with a data set. You have to break this data set into two half. You have to break this data set into two half. One known as the training set, and another is known as the testing set. Okay, one is known as the training set and another is known as the testing set. Okay, we are going to use a training set to train the model, and then we are going to use the testing set to test our model how better it occurs and how better result it gives. Is this clear? Is this clear? Yes or no? Is this clear, everyone? Yes or no? Okay, perfect. So I guess we can stop here for today. Okay. So this is about linear regression. This is just a basic of linear regression. They are much more deeper concept. The gradient descent. Gradient descent helps us to determine how we find out the value of M and C. Okay, don't take this combine as MC. It is M and C. Okay. Now this is all about linear regression, theoretical concept. Tomorrow we are going to talk about the practical concept of linear regression. We are going to see how we can perform linear regression. We are going to take a simple data set and we are going to perform linear regression. We are going to see how we can predict the value. We will going to see how we can find out the accuracy, and based on that You need to do a project, and about the project I am going to tell you day after tomorrow, in the last day. In the last day I will be sharing you all the material that has been used during the session, the Jamboard and your collab file. Is this clear? Is this clear, everyone? Is this clear, everyone? Yes or no? Okay, perfect. So now the moment that you guys are waiting for, the attendance. Let me send you the attendance. So here you go, and do check out this AlphaGo documentary. It will really going to help you out. Okay. So here you go. Attendance link has been posted in the chat section. Kindly go and fill your attendance. This is now the time for the doubt session. Come on. Any doubts? If you guys have any doubts, go ahead. See, pandas, NumPy, and Matplotlib is a part of data analysis, right? So tomorrow, when we are going to perform machine learning, we are going to focus on machine learning. We are not going to perform data analysis, but we are going to take some part of pandas, NumPy, or Matplotlib in account. Okay. Link for documentary. Let me provide the link for documentary as well. It's a very good documentary, right? So how a machine has beaten a human, right? So kindly look to this as well. Shaurya sir will be taking the next boot camp. You have to bear with me for 2 more days, and Shaurya sir will going to take the next boot camp. Okay. The other algorithm, see, we cannot cover all the algorithm in just a shorter period of time, right? So that's why we have covered linear regression. Otherwise, in the upcoming time, if we get some time, we can discuss. If you guys want to learn about some other algorithms, we can come up with another boot camp for that as well. Okay. Attendance link, let me share that again. Here you go. Attendance link has been shared with you in the live chat. If you guys have any doubt, kindly refer to the chat section, please. If you guys have any doubt, kindly refer to the chat section. Scope after BCA, what to do for masters or for a job? I would say try to get a job. Okay, if you can get that, that's perfectly fine, because if you're directly going to the masters, it will not going to make much sense. So I would suggest kindly to get some experience first, so that you will going to have a vivid domain. If you want to go into another domain, if you want to go MTech and so on and so forth, so I would say kindly go with job. If you can get one, definitely fine. Otherwise, you can go ahead with master. Not an issue with that. Is it necessary to learn Mldl to become data analyst? No, it is not necessary to learn Mldl to become a data analyst. For data analyst, you should know about data visualization tools such as your Tableau, Power BI, library. You should know R language, Python, SQL, Excel, and all that, right? Machine learning and deep learning is higher concept. Anyone else? Thank you so much. Thank you so much for joining in. Anyone else? Any more questions? What is the role of SQL in ML and data science? It has a huge role. See, SQL stores the data, right? SQL stores the data for you, and machine learning data science is all about data. So let's suppose the data source comes to be SQL. You get a SQL file, and from that file you have to fetch. You have to do the data analysis, and you have to do the prediction. Then you should know SQL to do that, right? How to deploy this model in real time? We have already done a bootcamp on that this year itself. You can check that out in our channel. That is the machine learning deployment of machine learning model with Flask. We have already done that. Kindly check that out, please. Okay. Any more question? Any more question? Day 3 and day 4 attendance has already been shared yesterday. Anyone else? Which one is better, C language or Java? You have to tell me the domain for which you want to go ahead with, right? They both are good at their own domain. So, what exactly is your perspective? Do you want to go with web development or something? On that perspective, I can tell you. Anyone else? Jobs that don't require coding. Oh, there are plenty of jobs. You can go with SEO, content marketing. Uh, what's more, you have content writing. So there are a lot of jobs. HR department. So that doesn't require any coding part. Class notes will be provided at the end of the bootcamp. For web development, I would suggest go with JavaScript. Okay, and if you want to have the backend with Java, learn Spring Boot. C will not going to help you out much in web development. Any more doubts? Are there enough jobs for data analysts as a fresher? Yes, they are. For data analysis, definitely they are. There are a lot of freshers jobs. Okay, and internships as well. Yesterday you have told that you will explain data science roadmap. Oh yeah, definitely. But since we don't have that time, let's skip that to tomorrow. Remind me tomorrow, right? So the first thing that we are going to do will be that only. Right? Really sorry for today. Thank you. Anyone else? Come on, guys. If you want to ask any doubts, kindly go ahead. So, in India, do company hire data scientists with high package? No, no. In India, company doesn't hire data scientists with higher package. No, the answer is simple no. You might get some exception, but on an average, no. Anyone else? Python is good for placement. I would say if you're sitting on placement, I would recommend you to go with C++ or C, not for Python. Which is better, data science or full stack? Based on your interest, you have to go with that program, right? So backend engineer with Python, yes, definitely you can go ahead with backend engineer. You for that you have to learn a framework such as Django, and you can go up with Python as well. Anyone else? Any doubt? Any doubt? Okay, I think in that case we can wrap this up. If you guys don't have any doubt. Uh, okay. What is the average package as a data scientist fresher? See, getting a job as a fresher is really difficult in the domain of data science. Even though if you're getting the average package will be lying between 3 to 5 LPA, and that will be a CTC, not the in-hand package, right? And if you have some experience, then you can go ahead with higher packages, right? Okay, I think that's the end of this day. If you don't have any more question, we can wrap this up. Uh, which one better to get hired? Which one better to get hired in Microsoft? Uh, you can go with data science, but moreover, you can aim for full stack. That will going to help you out in Microsoft as well. Companies that are hiring ML engineers, yes, there are plenty. There, you can go with Google, you can go with Facebook, because they are different section. Like in Google, you can go with YouTube, right? So YouTube should have a lot of ML engineers that predict that, because YouTube generates a humongous data for Google, right? So there are a lot of companies that require ML engineers. Okay, let me share the attendance link for the last time. And this is a wrap of today's session. I'm learning Flask and Django. Definitely, that's great. Congratulations. Which one is better? Being better at one programming language or knowing multiple language? I would say the midway of both is better. You should know one programming language, at the same time you should know about different programming languages as well. When I say different programming language, it doesn't mean that you have to know 10 backend language, you have to know 10 front end language. No, if you know one backend language, then study one front end language, right? For the backend, let's suppose you know Python, you have worked on Django. Now you don't need to learn about Node.js and all that. If you want to, you can go ahead with that, but you can easily use that particular language to do your work. Otherwise, you can go ahead and learn React or Angular or Vue.js. So it's totally depend upon you. Perfect. So in that case, we can wrap this up. Thank you so much, guys, for joining in. Have a great weekend ahead. Enjoy your week evening, and let's meet tomorrow with the day 6. Tomorrow we're going to see the practical implementation of linear regression. So make sure you all will be present there. And that's all from my end. Thank you so much. Enjoy yourself. See you all soon. Stay safe. Thank you so much. Bye.